can't wait to show you these two. Could quite possibly be the most one awaited problem in all of geometry, summer 2020, which is this number 10. But I'm going to batch in here number 9, because it's right next to it. Hello, help me out here. Okay, the measure of arc HGK is this thing, and that's 216. What is KHF? KHF is this one. So I looked at this one for a long time. I thought, oh man, maybe should I make relationships between 1, 2, and 3? Is this angle a right angle? No, it's not, because it doesn't go through the diameter. I'm not sure about that, but this is very similar to an inscribed angle. Here are the ones that we've kind of seen before. Inscribed angle. This is an inscribed angle. This one is a special one. You could also have, let's see, a chord and a tangent, something like that. And then this one here is none other than just an inscribed angle. And the measure of an inscribed angle is 1/2 the measure of its intercepted arc. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. Man, that one took me a long time, and I actually needed Mr. Wayne to show me, give me a hint for that one. I'm happy to give you a hint on this number 10, probably one of the most coveted videos I'm predicting, because it's diabolical. Let's simplify this a little bit and just draw triangle ABC without those gray lines that we were told that you can ignore. So here's triangle ABC. Here is an inscribed circle. That's the one in green. And that inscribed circle has tangent points at F, G, and E. And essentially what we are looking to find are, let's put in the angles here, 50.8, 85.3, and 43.9. So we're trying to find arc FG, arc EG, and arc EF. Essentially, what is the measure of that arc, and this arc? They all come together to form a circle. That's going to be pivotal. But for this one, you need this relationship, that the measure of, and here is let's picture the picture. Let's say we've got a circle and we've got two tangents coming off it that meet outside the circle. Well, let's call this measure of angle 1. The measure of angle 1 is 1/2 the difference between, we'll call it, I think this was Y and X. I can't remember what it was in the video, but it's 1/2 the measure of Y minus X. Essentially the big arc minus the small arc. Going to keep that there, but I'm going to make it a little smaller because we're going to need a lot of room here. And that's the theorem that you're going to use. Let's call this arc here, let's call it X. Let's call this arc Y. And before you keep going and call the arc GE Z, when you introduce a third variable, that's going to be difficult. We know the relationship between X and Y and the remaining arc. Remaining meaning it's left over from 360. 360 minus X minus Y. This is how I did it anyway. I think there's probably other ways, but this it worked out for me after a while. So let's start with this. The relationship here is that 50.8 is 1/2 the measure of 360 minus X minus Y plus X. See what I've done there? I've added this arc and this arc. So it's 360 minus X minus Y plus X. Then I have to take away Y. We'll clean that up a little later. Let's go on to the second angle, the 85.3 degree one. And that is 1/2, using the theorem again, of 360 minus x minus y plus y minus x. That is this 1/2 of this arc plus this arc minus this arc. We'll clean that up later. Let's find the third relationship. 43.9 equals 1/2 of, that's going to be x plus y minus this expression here. I'm going to put it in parentheses, 360, you should too, minus x minus y. Now let's clean this up a bit. Let's see, I'll change the color here and say 50.8 equals 1/2. Now the algebra in here, I've got a minus x and a plus x and a minus y and a minus y. So that's 1/2 of 360 minus 2y. Going to stop there and go to the next one. 85.3 equals 1/2 of 360 minus x, and a minus y and a plus y. The y's cancel in this case. 360 minus 2x. Last equation, 43.9 equals 1/2 of x plus y. Distribute the negative sign to all terms in that expression. Minus 360 plus x plus y. Now this third one can be cleaned up a little bit more. Let's see. I will do that down here and say 43.9 is 1/2. Let's see, I've got an x plus y and then another x plus y. So it's 2x plus 2y minus 360. Okay. Now, I'm going to highlight what we have so far. And you can go from there, but I'm going to show you another. This is no algebra. As your babysitting algebra teacher now, I'm going to show you something to make things easier. These fractions are not that fun. Instead, I would multiply both sides of the equation by 2, each one of those. It's called fraction busing. It gets rid of the fraction. So, and just, if in doubt, just write it out. I'm going to multiply both sides by 2, so I get, that's 101.6, need to get my calculator, that's a 101.6 equals 360 minus 2y. 85.3 is 161.6, is that right? 161.6. Oh, it's July. 85.3 times 2 is 85.3 times 2 is 170.6. 170.6 is equal to 360 minus 2x. And 43.9 doubled is 87.8. So I'm using this equation down here. 87.8 equals, when I multiply by 2 on both sides, the 2 times 1/2 essentially cancels. That's what's happening there. 2x plus 2y minus 360. What? Don't leave me. 360. 3 equations. If you look closely now, let's look closely. These top 2 are simply relationships with just one variable. So that means 2y equals 258.4. Y is 129.2. Can you finish the rest? Did it work out there? Does y equals 129? And y really is EF. That's 129.2. Okay, I think you've got the rest from here. Wow, where are we? This is you've stayed this long. Those 3 points are worth it to you. Good job, and thank you for doing a problem like this that is a perfect blend